Okay, and welcome to Records Part 2. Somebody knocked on the door, but I actually thought it was a good time to actually pause it and maybe split these into two videos. So let's get started. Let's have a look at where I was up to. We were talking about using records and mutating them. And also at this point within the documentation here. So we can see we were looking at a with. Now, with allows you to actually make a change to the data before the reference is passed back to you. So you can actually change anything, including complex types. So if you have any arrays in there, if you have any data that needs to be updated, it can be within the with clause. Now, just want to have a look at the abstract syntax tree for this. If you go deep into programming, you'll find that virtually every programming language has this abstract syntax tree, which is a way of representing how the code should look. And I find it really useful to be able to visualize and remember the process, because we can see here there's a syntax to this. We have a person here with age equals person. And what this is doing is this is actually the object type, then the with clause, and then the expression here to update the values of this object. So it's a little bit wonkier, if to use a term that someone I know uses a lot. What we can do here, we can see we've got a variable declaration of person B. The type is a person, but doesn't matter, which is identified as person B, the property name. Now there's a value clause with an equal clause, sorry, with a with expression. And this with expression can take any list or an array of property assignments, which means that you can pass in pretty much unlimited number of properties here to override the values of the person. So that's the way that this works and the way that the with is put together. Okay, let's have a look at inheritance. It's possible to use inheritance with records. In fact, I highly recommend you look at using inheritance when you're creating any kind of objects, because it allows you to do the is a type comparison. So I'll show you, hopefully I'll show you a couple of examples of that later on. So here we've got a person, which is they have a name and they have an age. But a person could also be an employee. So this person gets employed, they become an employee, and their employee has a name, an age, and a job title. So we can extend this, and we can see that we will pass in person, which is a name and age, but employee has a job title. Now that means that technically this record only has a job title, and this record only has a name and age. But when they get stitched together because of inheritance, they get both. Now it also means that when you're writing your code, you can check if your object type is a person, and you can also check if they're an employee, which means if they're an employee, you get to do things with that employee object. For instance, print out the job title, where if they're not employed, you wouldn't print out the job title and you would get your code to do something else. This is really, really powerful because we can finally, instead of having to write thousands of lines of code, we can create domain-driven contextual object types. If we pay close attention to this as well, you can also see that I have got a lambda function, which is printing out the person's name and age, but I'm also getting the job information. So if I have an employee object, I can get the job. And if I've got a person, which I always have, I can get the basic information. So I can get the basic information from an employee, and I could also get the job information from an employee by extending and adding methods to a record. Just as you would write methods to a class, it is possible to extend a record. So here we've got a record here, which is mimicking a car. And we can actually see that this has a stop and a start method. And we have a status, which is state. So just let this seep in. Just keep an eye on this. We've got a car which has got a VIN number and a make and a model. It has the CC size and the cylinder count. Apologies to every car person on the planet if I've got all this hideously wrong. But here we can see that a car has an engine, and we can pass that in. An engine has the ability to be started and stopped, and therefore it has a status of whether it's running or not. Now, an engine can run without a car. You can mount the engine without the frame, without anything, and run an engine. So it's possible for an engine to be started and stopped in the factory before it's even put into a car. So with this, what we've got the ability to do is we've got a Honda Accord that we've constructed. We've passed in the engine size and the number of cylinders, and we're able to start and stop the car. When we do this, we can see that the state has changed. We can see that it's running, and we can see that it's stopped. However, these objects should be immutable, right? They don't change. Well, here we can clearly see that we are changing the state of the data, but we're doing it from inside the record, which means the record's allowed to change itself. It has the power to change itself based off the rules that it's been designed to do. And the person who coded an engine knows that a car can start and stop. It knows that that state is useful to know from the outside world. So here we can see that we have a car that can start and stop. And like I said, wait, you said records are immutable. Well, they are from the outside looking in, but a record can be changed by itself.